Idaho Matters podcast is brought to you by St. Luke's On-Demand Virtual Care, which allows patients to see a provider from their home using a computer or smartphone with on-demand care for common ailments such as a cough, sore throat, or a sinus issue. More information at stlukesonline.org.
Boise State Public Radio, because of you.
Well, I feel if you're listening to it even occasionally, you're reaping the benefits. And I think you really need to think about what the world would be like without public radio, without this very different format. Just think of what the world would be like without that. For me, it was a pretty clear-cut choice.
We do it because of you. Thank you for your support at boisestatepublicradio.org.
You're listening to Idaho Matters from the studios of Boise State Public Radio News. I'm Gemma Gaudette. Did you know that up in the night sky, alongside the planets, the moons, and the asteroids, there are also cosmic relics? They're called globular clusters, and they're billions of years old. You can see them in the Milky Way, and these group of stars give us insight into the earliest days of our galaxy, which is why Dr. Madeline McKenzie spends so much time studying their light. And we're lucky enough to have her join us now to talk more about what her research is uncovering. Welcome to the program.
Hi, thanks for having me.
So can you start out today by telling us a little bit more about your research and what exactly it focuses on?
Yeah, absolutely. So I'm an observational astronomer at the Carnegie Observatories. So I use information in starlight to understand different properties of stars. My area of research is called galactic archaeology. So just like an archaeologist might go to the pyramids to study the lives of ancient Egyptians, I look at some of the oldest objects in our galaxy to understand the properties of the early universe.
So I mentioned a little bit earlier, but tell us more about what these, ancient relics are and why they're so important.
Yeah, globular clusters are important to the Milky Way in the same way that looking at fossils are important to Earth. By understanding the elements inside globular clusters, we can start to piece together what elements were around at the beginning of the universe, in the same way that we use fossils to understand what plants and animals were around before humans arrived.
Okay, so you mentioned globular clusters. What exactly are they? They sound like a candy.
Yeah, exactly. Yeah. So these are giant spherical balls of stars. They're made up of hundreds and thousands of stars. And fundamentally, the stars inside a globular cluster are the same as what the sun is. They're fusing elements together to create energy. The big difference between the stars inside globular clusters is that they're about double the age of the sun, 13 billion years old. And so they have very different elements inside of them.
So are globular clusters, are they different from the stars that we typically see in the sky?
Yeah, they're basically like any, and you can see globular clusters with the naked eye, and they're just these kind of fuzzy blobs. And they're a really popular target for amateur astronomers. So if you go to an astronomy night, you'll usually end up seeing one of these globular clusters. But I don't think people appreciate just how old these things are. They're the oldest things you can really see with the naked eye.
Okay, so can you talk a little bit more about that? How old they are? I mean, how do scientists determine their age and how old are we talking about here?
Yeah. So age is actually a really difficult thing to determine in astronomy. And there are a few different approaches that people use, and they have these long and complex sounding names like astroseismology or nuclear cosmochronology. But by far the most common method used for age dating globular clusters is called isochrone ages, where we take the color and the brightness of all of the stars inside this cluster and compare this to models of how stars evolve. And this usually gives us an estimate that's accurate to about 500 million years, which seems pretty inaccurate to most people.
Yeah.
But when you're talking about something that's 13 billion years old, 500 million years isn't that bad. It's pretty good, actually.
You're not too far off. Okay, so my understanding is you use stellar spectra in your research. Can you explain to us a little bit more about what that is?
Yeah, I love stellar spectra so much. So everyone's heard of a rainbow, right?
Hmm.
Well, my job is so cool. I get to study space rainbows. So I
Oh.
collect starlight in a telescope, which is essentially just a big light bucket. The larger the bucket, the more light you collect. And then we can break that light up into a rainbow, and we can measure the properties of this light using an instrument called a spectrograph. And we can determine how fast an object is moving towards us or away from us. And we can tell what elements are inside the star. And that's what I generally focus on.
So, how does light help you understand the history of the universe?
Yeah. If we figure out what elements are inside globular clusters, we can figure out what elements were around when the universe was only a billion years young. And this can
Hmm.
tell us how many generations of stars might have formed before the clusters, things that have gone through and exploded, and we no longer see them anymore, but we see traces of them, their heritage. And we can figure out what kind of elements they were fusing together and what sort of lives those stars were living. So if we look at our globular clusters, we can then figure out what the early Milky Way was really like.
So, let's talk a little bit more about these globular clusters because are they unique to our galaxy or do we see them in other places in the universe?
Yeah, we see globular clusters around most galaxies, actually. And the larger the galaxy is, the more globular clusters it tends to have. So there's quite a few of them out there for us to study.
So, how does comparing these clusters does it deepen your understanding of the universe?
Yeah, it's all of this big question of, understanding where we come from. Where does the elements inside of our body come from? The gold, the, uranium, the thorium, all of these weird
Hmm.
elements, even just the carbon in our bodies. Where does that come from? And how is that created across the lifetime of the universe? And so, because we've got these essentially little time capsules floating around us that are really close that you can see, you can go out and see them tonight. There are these amazing vessels of understanding where we come from, essentially, in this really big picture of the universe.
So, I'm curious. Has there been anything surprising, maybe a surprising discovery that you or other scientists have made recently about globular clusters or our early galaxy formation?
Yeah. So I study the nearby globular clusters, but I have a lot of colleagues who are using the James Webb Space Telescope that people might have heard of. It's this incredible instrument that was sent up into space very recently, and it's looking so far back in time. It's looking so far away that people think that they might be seeing the creation of globular clusters itself 13 billion years ago. So that's how
Oh.
incredible the instrumentation that we have on Earth today, that we can look so far back, almost to the beginning of the universe, and potentially see signatures of globular clusters forming. But there are still a lot of unanswered questions. These are really, really hard measurements to make. And so,
Hmm.
what I'm doing is try to provide the best understanding that we can of globular clusters in our neighborhood so that the people using the JWST Space Telescope can try and piece together, are they actually seeing globular clusters or are they seeing something even weirder back at the beginning of time?
So you just mentioned there's still a lot of unanswered questions. What would you say is one of the biggest unanswered questions in your field right now?
Yeah, the one that I'm really focused on is that we actually don't know how globular clusters formed. So there are specific chemical signatures inside the stars that suggest that these stars must have reached temperatures of over 80 million degrees Celsius, which is
Mm.
just unfathomable to think about. And we don't know in what environments stars can create such incredible temperatures. And we don't understand how we can take that material from these stars and then cool it down and form new stars from it to create these unusual chemical patterns. And so, what I do is I study the signatures of specific nuclear reactions that can happen inside stars and trying to answer this question of how do we form a globular cluster that we know today that has all of this complexity when we look at the elements inside their stars.
So, why do you think people should be excited about studying the earliest history of the universe? I mean, what impact do you believe it could have or is having on us today?
Yeah, this, is a really important question to consider with everything happening in the Earth right now. I think astronomy tends to be like this gateway into science. We have these really incredible, cool questions that we can ask and answer. And a lot of the time, that can lead kids and young people to figure out what they want to study and ignite this curiosity. I think what is special about globular clusters is that it's answering this question of what was the universe like when it was very young. We do DNA tests on our for each other, and we try and
Hmm.
figure out our heritage, where our ancestors come from. We study the Earth and planets to understand where they come from, the stars and the sun and the Milky Way. And the biggest fundamental question is, where did the universe come from? And these are these big questions that the NASA Hubble Fellowships supports, and I'm very grateful to be receiving funding for this research. And globular clusters are just one little piece of that big question of how did the universe evolve to get where it is today.
So, before I let you go, can you talk to us a little bit more about this topic because you're going to be talking about it tomorrow at First Friday Astronomy. So, just remind us when and where people can come and hear you talk more about this.
Yeah, tomorrow it will be 7:30 in the education building, I believe. And I'm hoping that afterwards the sky will be clear enough where people can use some telescopes and see globular clusters with the naked eye, which is this incredible thing because you hear about exoplanets and supernova and black holes, and there are all these exciting things, but they're never something that we'll be able to use our own eyes and look at. Globular clusters are one of those things. So I'll be giving a bit of an overview of, some of the globular clusters that we can see in the night sky and what we know about them from the spectroscopic point of view, so what elements are inside them and what that can tell us about the lives of these clusters. And so I hope people can kind of get an understanding of the things that are in our backyards and how truly exciting they are.
Well, I want to thank you so very much for taking time to talk with us today. We've been speaking with Dr. Madeline McKenzie about the history of our galaxy, and she will be talking more about ancient relics of the early Milky Way tomorrow, April 3rd, at First Friday Astronomy. It's sponsored by Boise State's Physics Department. That'll happen at 7:30 p.m. in the Education Building. And thanks so much for listening to Idaho Matters from Boise State Public Radio. Do you have thoughts about today's episode? Make sure you email us at idahomatters@boisestate.edu or reach out on our socials. Find this and other Boise State Public Radio podcasts on Apple Podcasts, Spotify, or wherever you're listening right now.
If you like podcasts like this, explore more from the Boise State Public Radio podcast family. There you'll find a mix of daily news, Idaho Voices, and in-depth series on a wide range of topics. I'm talking wild horses, political scandals, sustainable ranching, and militia groups in a post-January 6th world. Wherever you get your podcasts, just search Boise State Public Radio to find what Idaho's NPR station has in store for you.